In the Beginning by Dr. Walt Brown on page 208, Liquefaction, water lenses. An important phenomenon, which will be called lensing, was observed in the sediment tank. Some layers were more porous and permeable than others. If water flowed more easily up through one sedimentary layer than the layer directly above, a lens of water accumulated between them. Multiple lensing formed simultaneously, one a short distance above the other. Water in these nearly horizontal lenses always flowed uphill. Throughout the flood, countless water lenses grew and then decreased with each wave cycle. During liquefaction, organisms floated up into the lens directly above. Water's buoyant force is only about half that of liquefied sediment, so a water lens was less able to lift dead organisms into the denser sedimentary layer directly above the lenses. In each geographical region, organisms with similar size, shape, and density, usually members of the same species, often ended up in the same lens. There, they were swept by currents for many miles along these nearly horizontal channels. Coal. Vegetation lifted by liquefaction into a water lens spread out and formed a buoyant mass pressed up against the lens's roof. Vegetation mats composed of thin, flat, relatively impermeable sheets, such as intertwined leaves, ferns, grass, and wood fragments, could not push through that roof. These mats also prevented sedimentary grains in the roof from falling to the floor of the lenses. Each vegetation mat acted as a check valve, that is, during the portion of the wave cycle when water flowed upward. The mat reduced the flow upward through the lens's roof, so the lens volume grew. During the other half of the wave cycle, when water flowed downhill, the mat was pushed away from the roof, allowing new water to enter the lens. Therefore, water lenses with vegetation mats thickened and expanded during the flood. Vegetation mats became today's coal seams, some of which can be traced over 100,000 square miles. Figure 106, liquefaction and water lenses. The wave cycle begins at the left with water being forced down into the seafloor. As the wave trough approaches, that compressed water is released. Water then flows up through the seafloor, lifting the sediments, starting at the top of the sedimentary column. During liquefaction, denser particles sink and lighter particles, the dead organisms, soon to become fossils, float up until a liquefaction lens is encountered. Lenses of water form along nearly horizontal paths if the sediments below those horizontal paths are more permeable than those above, so more water flows up into each lens than out through its roof. Sedimentary particles and dead organisms buried in the sediments were sorted and resorted into vast, thin layers. An unpublished experiment in Loma Linda University, a dead bird, mammal, reptile, and amphibian were placed in an open water tank. Their buoyancy in the days following death depended on their density while living, the buildup and leakage of gases from their decaying bodies, the absorption or loss of water by their bodies, and other factors. That experiment showed that the natural order of settling following death was, from the bottom up, amphibian, reptile, mammal, and finally bird. This order of relative buoyancy correlates closely with the alleged evolutionary order, but of course evolution was not the cause. Other factors influenced burial order at each geographical location were liquefaction lenses, which animals were living in the same region, each animal's mobility before the flood overtook it, and the animal or plant's shape. How much fluid drag from the upward flowing water lifted the organisms. Cyclothems. Sometimes 50 or more coal seams are stacked one above the other with a special sequence of sedimentary layers separating the coal layers. A typical sequence between coal seams from top to bottom is sandstone, shale, limestone, and finally denser clay graded up to finer clay. These cyclical patterns, called cyclothems, are in the order one would expect from liquefaction: denser, rounder, larger sedimentary particles at the bottom and less dense, flatter, finer sedimentary particles at the top. Cyclothems layers worldwide generally have the same relative order, although specific layers may be absent. In the Beginning by Dr. Walt Brown, You can get this at creationsciencecenter.org, the flip book.